Hey there, how are you? Welcome to Joey's Tech. In this video of Joey's Tech, we are going to solve together the problem of largest divisible pair subset. When it comes to mastering dynamic programming problems, you have to solve enough problems and their variations. Now, this problem is a variation of one of the major dynamic programming problem. I'll tell you what that problem is while we solve this problem. So all you have to do is keep watching this video. Now let's take a look at the problem statement. Yes, so all you are given is an array of n distinct beautiful elements. All you have to do is find the length of the largest subset out of this array with the following condition. The condition is that each pair of the subset has to be such that the smaller integer of the pair divides the greater integer. Now this is our array 10, 5, 3, 15 and 20. So these are all the elements. Now I take out the subset 10, 5 and 20. Now you take the first pair, which is 10 and 5. You see that 5 is the smaller integer and 10 is the greater integer. So 10 is divided by 5. Similarly, if you take the next pair, which is of 20 and 10, 20 is divided by 10. So this makes it as a divisible pair subset. Now this is the largest divisible pair subset and its length is 3. So that is what we have to find out using dynamic programming. And this is our problem. Now we are going to switch to our framework where we are going to solve this problem. Before we move there, if you haven't subscribed to my channel yet, please do so. Please hit the subscribe button and the bell icon, because that way you will get notified whenever I release videos like such for you in future. Let's switch to the framework now. You see that I have put the problem array over here. 10, 5, 3, 15 and 20 are the distinct elements of our problem array. Now the first step towards solving this problem is to sort the array in descending order, like I have done here. Why we do that? Because we need to find a subset in which there are pairs in which the larger integer is divided by the smaller integer. So it would be better to bring the smaller integers on one side and the larger integers on the other side. Therefore, I have sorted the array in the descending order. Now this problem is a variation of the longest increasing subsequence problem, so it will be solved in the same manner, kind of in a similar manner. This is our solution array, and here are my two variables j and I. I will keep moving towards the right and j will move away from I in the left hand side. So as we progress, you are get an idea. Now let's start solving this problem. Alright, so we'll start filling our solution array now. We'll start from the first element, but we'll have to fill the base element first, which is this cell. So the value of this cell is going to be 1, because just for the picturization purpose, if the problem is limited to this cell, that means only if it has 20 in the array, then the length of the largest divisible pair subset is going to come out as 1. So that is what I have populated here. Now I am going to populate the other cells of this array with 0. And as we solve, you are going to understand why. Now one thing you have to remember is that I is going to move towards the right and j is going to move away from I, because we will be moving from smaller to larger integers, and the larger integers are on the left. So we calculate the value of this cell now. So I represents 15 and j represents 20. So is 20 divisible by 15? No. So what is going to happen in this case? We are going to simply add 1 to this 0. Hence the value of this cell is going to be 1. So if you see this subproblem, which has only 20 and 15 in the array, then the length of the largest divisible pair subset is going to be 1 only. That means every man for himself. Now I is going to move one cell to the right and j is going to come back to its base position, which is one cell to the left of I. Now here j represents 15 and I represents 10. Is 15 divisible by 10? No. Alright, so nothing happens. Okay, now j moves one cell to the left. Over here j represents 20 and I represents 10. So is 20 divisible by 10? Yes, it is. So in this case, what is going to happen? We are going to compare the two values. So the one value will be represented by j and the other value will be represented by I. So between 1 and 0, which is maximum, 1 of course. So 1 will be populated here. Now all our iterations by j are over. So in the end, what we are going to do? We are going to add 1 to this value stored over here. So this will become 2. Why I have done so? Because I have got one more integer in my subset. Okay, so this particular I is representing one more integer in the subset. So plus 1 is for that, and the value earlier came from this cell. So 1 added to the value gave me 2. So now if you consider the problem till here, we have the largest divisible pair subset as 2. Okay, now I moves one cell to the right and j comes here. Now j represents 10 and I represents 5. So is 10 divisible by 5? Yes, it is. So what we are going to do? We are going to pick out the maximum value out of the values represented by j and I. So which is maximum? Between 2 and 0, it's 2. So 2 gets populated over here. Okay, now the iterations of j are still not over. So j is going to move one cell to the left. So is 15 divisible by 5? Yes, it is. Yes, it is. So we are going to compare the value represented by j with the value represented by I. So between 1 and 2, which is maximum, it is 2. So 2 stays here, 1 gets eliminated. Now j moves one cell towards the left. J represents 20, I represents 5. So is 20 divisible by 5? Yes, it is. So we'll have to compare 1 and 2 now. 2 is maximum again, so 2 stays, 1 gets eliminated. Now in the end, after all the iterations of j are over, we are going to do plus 1 to this value because it is for 5, the number which I represents now. So 2 plus 1 is going to give me 3. Okay, now j goes back to its base position and I moves here. So j represents 5, I represents 3. So is 5 divisible by 3? No way. So nothing happens. J moves one cell towards the left. Now is 10 divisible by 3? No. So nothing happens. J moves one cell towards the left. Now is 15 divisible by 3? Yes, it is. So between 1 and 0, we are going to pick out the maximum value. So 1 will be populated over here. Cool. Now j moves one cell towards the left. J represents 20, I represents 3. Is 20 divisible by 3? No. The remainder is not going to be 0. So in that case also nothing happens. Now when all the iterations of j are over, so we are going to do plus 1 to this value over here, stored over here. So 1 plus 1 is going to give me 2. So now what I have to do is pick out the maximum value from this solution array, which is 3. So 3 is the length of the largest divisible pairs subset, like we saw in the previous slide. So 3 is the length of the largest divisible pair subset, like we saw in our slide. Now let's take a look at its algorithm. So this is our algorithm. As you can see, that first we'll have to sort the array, problem array, in descending order. Then we are assigning the first cell of the solution array 1. Now here is the loop of I, which is going to start from first cell and is going to go all the way till the last cell. And here is the loop represented by j, which is going to start from the cell immediately left of I every time and is going to go towards the left. Now when the integer represented by j is divisible by the integer represented by I, then dpi is going to be the maximum of dpi and dpj. And in the end, when all the iterations of j are over, then dpi is going to be 1 plus the value already stored in there. Finally, we'll get our final result by choosing the maximum value from the dp array, which is 3 in our case. So with this, we have come to the end of our video. I hope you enjoyed watching this video. Do give it a thumbs up. I look forward to help you with algorithms and programming. Do tell me what you think about this video in the comment section. And only for this video, goodbye.